Hi, so today I'm going to go through a bit of CL, and CL stands for Computation Layer for Desmos. And CL can be used for so many things. It can give students feedback, it can tell the teacher if the student's correct, it can start animation, it can start a timer, it can reveal answers, it can hide things. There's just so many things that CL can do. So we're just going to get our feet wet today with a very small piece of it, and that is checking for correctness for a few different things in math input, as well as this first slide, which is multiple choice. And I think I'm going to be splitting this into two videos, so watch both, just so that I can cover each thing that I need to here. When I go through the CL in this video, I'm going to be thinking about sort of two different things. The CL that we're writing is going to check the student answers and let the teacher know how the student did on the answer. So either on the student dashboard, it'll have an X indicating that it's wrong or that some of it's wrong, or it'll indicate a check mark if everything's correct on that slide. The other thing that I'm thinking about when I'm teaching UCL is sort of like, once we learn the basics and we want to do more with it, we kind of don't want to relearn things and re-edit all of our activities. It might be nice if I have you learn it so that it's set up nicely to just build off of to do more, rather than sort of restructuring things. So when I teach it today, it's going to be a little bit more writing, just very slightly more, than it otherwise needs to be. And by doing that, it'll set it up nicely for what's to come in the future. Especially when I think about things like giving students feedback in whatever form that is. All right, so let's jump right in. So before we actually look at this question, I just want to say that each component is going to have this little symbol on it, and that allows you to go into the computation layer, which is CL. When you go into any one of these, you want to write the code in this part. And if you need help, Desmos has put together a really nice documentation on CL. And you can just click on this in any computation layer box that you're in. You can get to their documentation by just clicking the link. So definitely check that out. All right, so previewing this question, we can see the question right here, which is the same as one of my other videos, and then the answers below. And the dashboard preview is right here. So if I click 10, I get a dot, 13 a dot, 28 and 30. Each of these will give me a dot on the dashboard preview for teachers, which means, hey teacher, you got to check this slide out because I don't know if it's correct or not. So let's tighten that up a little bit. On a question like this, it's quick for the computer to check if it's correct or not, and that saves the teacher a lot of time. So we're going to go into the computation layer, and we're going to name a variable called check, which just means I want you to check this. And then we need to name the type of component. So there are tables, there are graphs, there are sketches, there's math inputs, there's all sorts of things. And so this one's a multiple choice, but we don't actually even care because we can just write this, which means this one that we're typing in right now is the one that we want to talk about. So you can save yourself some time by writing this. And then you want to put a dot and then select from those options that pop up. So we want is selected. When we're talking about is selected, what does the student select that should be correct? And it's going to need a number inside the parentheses here. And that number is not going to be 10, 13, 28, or 30. It's going to be either 1, 2, 3, or 4, meaning the order in the list that the answer is. So if I select the number, if I type in the number 1 in my CL, then I mean that the answer 10 is correct. But I don't want that. I want to type in the number 2, meaning that 13 is correct. So going back to the CL, I'm going to put 2, meaning the second thing in my list is what is correct, 13. And if I leave it at this, then the computer's not able to do the work that I want it to do by telling me that it's correct, because I haven't yet said that that is what makes it correct. So let's do that right now. Using Desmos sync, I think is what it's called, of correct, we can write down that check. So if check is if the check passes, if it is true, then we want it to mark it as correct. So if in this component the second option is selected, then I want it to mark that as correct, if that's what the student has selected. So going back to our preview, we can select 10 and it'll mark it as wrong. 13, it'll mark it as correct. 28 wrong, 30 wrong. And even if you tell the computer to jumble these answers up, as long as you have marked it correctly from what your answer key says, it knows that it's swapping the order and it'll keep track of that and it'll still mark it correct accordingly. So one quick thing that I mentioned in one of my other videos is that you don't even need the CL for that. You can just click the bubble right there and it'll mark it correct or incorrect. However, if you're going into more complicated things, like revealing answers or having the student answer then transport to the graph, or whatever it might be, then doing things like what I've set up in the CL today will help you with those other activities as well. So it's sort of not just getting by for now, but also setting it up for the future. Let's look at the second slide here. This is exactly the same question. The answer is 13, but instead of multiple choice, we have a math input. So we need to write the CL accordingly for that. We're going to go to the CL. We're going to start off the same. Check is what I've started using just constantly when I use this. And then whatever my check criteria is, I put it into my correctness criteria. Sometimes I do a check 1A, check 1B sort of thing if I need to as well. Or sometimes I name it a little bit more clearly than that. So what do we want to check? We want to check that this component, again, it doesn't matter if it's a multiple choice, a graph, a table, because it's this one. But if we want to reference a different one, then we need to make sure that other one's named, which I haven't shown you yet. And then we need to reference it here. But we're just keeping it simple with this. We want a numeric value. We want the answer to be 13. So if the student in this component writes an answer that's a number and it is equal to 13, then it passes our check. And if it passes our check, then we want the computer to say that it's correct and give that check mark. So we're going to go to preview. And if the answer that the student types in is a 2, the dashboard on the teacher side of things is going to be wrong. And if the student types in 13, it's going to be correct. They can type in anything that is equivalent to 13. So 13.0000 or 13 over 1 or 26 divided by 2. Anything that becomes 13. So they could write 2 times 5 plus 3, which might be problematic for you if you want them to figure out that that's equal to 13. So if you need to, you can tighten this code up a little bit by going into here and saying and, count number usage. So how many times does this number show up in the box where the student writes their answer? How many times is in this LaTeX does the number 13 show up? It should show up once. So now if I go back and I type in 2, it's wrong. If I type in 13, it's correct. If I type in 26 divided by 2, it's marking it as wrong because it has to be specifically 13. So if you're going to ask for something that's very, very specific like that, then make sure that your directions are pretty specific, like maybe fully evaluate or something. So I'm going to end video 1 here and pick up with me to see the last 2 slides with CL in the next video. Okay, bye.